Jai Hind, welcome to the course Network Analysis and Synthesis, and today I am going to discuss about the transient behavior of RC series network. So in this, first we will discuss what is transient response. Then we will discuss what is steady state response, and then we discuss what is complete response of a network when it is excited by some input. So, we'll just discuss all these three topics today. So, first, what is transient behavior? So, transient behavior, we mean the manner in which response goes from initial state to final state, and it prevails between two steady states. So, suppose this is your circuit, okay, and this is your RC circuit. This is your some input, this is your R and this is your C. So, before the switch is closed at, suppose at t is equal to 0, switch is closed. So, before the closing of the switch, it is in a steady state, means at t is equal to 0 minus, it is in a steady state, and at t is equal to infinity, it is in steady states. So, both these two states are steady states before closing of the switch and when the switch is closed for a very long time. So, these two states are called steady states, and transients prevail for a very short duration in an electric circuit between two steady states. So, these are the two steady states before switching of the circuit and when the circuit is closed for very long time, say t tends to infinity, then it is called steady states. So, what are the phenomena and what are the causes due to which the transient phenomena occurs? So, first is when the circuit is suddenly closed or opened from the supply. So, when the circuit is closed, connected to the supply, or it is disconnected from the supply, then transient occurs. Second, a sudden change in the applied voltage from one finite level to another finite level. If we change the voltage level from one level to another, then the transient occurs. And the third is when the circuit is short circuited. So, these are the three causes due to which the transient phenomena occurs. So, transient currents are not caused by any part of the supply voltage, but are entirely associated with the changes in the stored energy in capacitors or inductors. So, these are the causes of transient phenomena. So, first we will discuss the transient behavior of a series RC circuit subject to step input. So, we consider a series RC circuit. This is your switch and this is your supply. See, and say this is the initial voltage across the capacitor is V0 and it is excited by some input which is given as VUT, and switch is closed at t is equal to 0 and we are required to find the IT. Yes. So step input. So input is VUT, where UT is 1 for t greater than or equal to 0, 0 for t less than 0. So switch is closed at the switch is closed. The switch is closed. Switch is closed at t is equal to 0. Then we can write the dynamics of the circuit. So we can apply the Kirchhoff's voltage law to get the equation. So it is VUT equal to R IT plus say 0 to t current IT into dt. So it is integral equation. So to solve this equation we can apply the Laplace transform. So take Laplace transform on the both sides. So take Laplace transform on both sides of the above equation. Both sides of above equation. Okay. So this is the UT. So the Laplace transform of UT is 1 by S. So V by S. It is RIS plus 1 by SC IS plus V0 upon S. This V0 is the initial voltage, or you can say the charge across the capacitor. So V0 is Q upon C. So Q upon C is the initial voltage. So initial voltage is present over the capacitor. So it is now. So V upon S minus V0 dash upon S equal to R plus 1 by SC into YS. Okay. So it is the integral equation becomes the algebraic equation once we apply the Laplace transform. So algebraic equations are solved by algebraic manipulations. So to get the response, what we do, take the inverse Laplace transform. So first we just write one more lines. So we call, so IS is V by S R plus 1 by SC minus V0 dash upon S R plus 1 by SC. Okay. So try to simplify this. So it is V by S and this is SRC plus 1 upon SC minus V0 dash upon S SRC plus 1 upon SC. So take RC outside. So it is, first we take on simplifications we can take. So it is one more lines we can write before taking the inverse. So V S, this is your RC take out upon SC, S plus 1 by RC, okay, minus V0 dash upon S RC outside. So it is 1 plus S plus so it is S plus 1 by RC upon SC. So this cancel out, this cancel out. So it is, so V by R S plus 1 by RC minus V0 dash upon R S plus 1 by RC. So this is, so look at here. Here this is in S domain. So if you take the, suppose I am taking complete this, taking inverse Laplace transform. So here you can write taking inverse Laplace transform. So IT is V by R e to power minus T by RC minus V0 dash upon R e to power minus T upon RC. So there are two components we can clearly see. So this is called your forced response. Forced response. And this is called your free response. Free response. Free response, or you can say, or natural response, or natural response. Why it is called free response? Free response means free response, or you can say the response due to initial condition. Response due to initial condition. So it is called free response. So this component is called free response, and this is called forced response, and both as a whole known as a complete response of the system. So we can write IT is equal to V by R, we can take the outside, minus V0 dash upon R into e to power minus T upon RC. So what is RC? What is RC? What is RC? So RC is time constant of series RC circuit. So look at here. So this is your input, this is your initial condition, and this is called complete response. If suppose if initial voltage across the capacitor is 0, capacitor is 0, that is V0 dash is 0. What will happen? So the IT is, then we can write IT is V by R e to power minus T upon RC. So look at T is equal to 0. T is equal to 0. So I0 is T is equal to 0. It is V by R. ठीक. Now at T is equal to infinity. At T is equal to infinity means steady states. So when T tends to infinity, this becomes 0. So the ISS is 0. So steady state response is 0. Steady state response of the circuit is 0. So if you try to plot this, so what we can conclude. So IT is your IT is V by R e to power minus T upon RC. Okay. ISSS is 0. So ITR means transient response. We can say the transient response. Response we can say IT minus ISS. So it is V by R e to power minus T upon RC. So you can plot this curve. This is your time axis T. This is your IT. So at T is equal to 0. At T is equal to 0, its value is V by R. So it is V by R. And at T is equal to infinity, I infinity is 0. So it is going like this. The curve is like going like this. And at T is equal to 1 tau, if we get the, suppose it is 1 tau, it is your 1 tau. So 1 tau, its value is 0.37 V by R. So this is the transient behavior of. So we can write here when t is equal to 1 tau. So 1 tau. So I at 1 tau is V by R e to power minus tau upon tau. So it was minus 1. So it is V by R upon 1 by E and so on. So this will go like this. This will go like this. So this is the transient behavior of series RLC circuit. This at t is equal to 0. So its value is, so it is decaying. It is asymptotic. It is asymptotic along time axis. So what is free response? What is free response? Is the response when there is no input, when the circuit having no input. So it is like this. Suppose circuit is like this. Circuit is like this. This is your C, and this is your R, and this is having some voltage, and you are required to find the response. To find the response, it is called free response. Free response or natural response. Okay. What is the forced response? Response due to some input source. When the circuit is excited by some input and you are required to find the response, that is called the free response. And if there is any initial condition is present and if the input is absent and you are required to find the response, then that response is called the free response. So we discussed when the circuit is excited by step input. The circuit is excited. When the circuit is excited by impulse input delta t. So we can write delta t is equal to delta t. So V delta t, say V delta t. So we can draw the circuit. This is your switch, this is your input, and this is your circuit, and this is V delta t. This is your R, this is your C. So at t is equal to 0, switch is closed. So V delta t is equal to RIT plus 1 by C 0 to t IT dt. Take the inverse Laplace transform. So we can write V delta t. So V delta t. So the Laplace transform, the Laplace transform of impulse function is 1. If we take the Laplace transform, so it is V. So V is equal to RIS 1 by SC IS plus V0 dash upon S. So this way we can, so V minus V0 dash upon S is equal to R plus 1 by SC into IS. Take inverse Laplace transform. We can find the IT. So procedure is same. Whether the input is your step or impulse or even the sinusoidal, procedure is same. Take the Laplace transform and solve the algebraic equation. In the last, we take the inverse Laplace transform to get the response of the circuit. So this is all about your transient behavior of series RC circuit when it was excited by step input. It can be excited by any other input, whether it is impulse or sinusoidal. Approach is same. So just we stop here. So thank you very much. Jai Hind.